Hi guys, we're going to have a look at question 3. So in this particular case we've got a radioactive waste box which is going to be used to enclose some highly radioactive stuff using a lead in a volume. So in this particular case we're again going to follow through A, B, C, D and have a bit of an understanding here. So we know that the base dimensions are 2:1, so obviously if our value over here is x there, then we could probably label this side over here 2x, couldn't we? So now we know the dimensions of our box. Now it says explain why x squared h equals 100. Now in all of these cases I said before, there's always something that you get given that you're going to use to find one term in terms of another one. So if I look at that, I've been given the volume, so it's a bit obvious I need to use the volume formula. So we know the volume is equal to 200, and the volume of my container, which is a square base, it's a square base pyramid or a cube, or like a cylindrical, not a cylindrical box, but it's a box there of dimensions 2x by x by h. So therefore I could say that 200 equals 2x squared times by h. And so therefore you can cancel that over there with that, becomes a 1 and 1. And so therefore you've got 100 divided that by x squared will be equal to h. So we've shown that. So you have to explain or show why, which means you've got to do the steps. Alright, so that's the key idea there. Going to the next bit of this question, explain why the inner surface area of the box is given by that. Well, if you think about your 2D net for that particular shape, right, so you could draw your 2D net. We'll just draw it over here. So we're going to have a few, obviously you can do a better sketch than I'm going to. So that's going to be 1, 2, 3, 4, and then you're going to have two sections like over here. Alright, so if you know that's going to have a dimension of x on all of those, that's going to be 2x over here, that's going to have a height of h. Okay, so for that, so what you'll find with the box is, and the surface area of any of these boxes is going to be two lots of each of the sides, because you've got two lots of each of the sides, so it's going to be x times by 2x, it's going to be plus x times by h plus 2x times by h. Alright, so that will give me, obviously I can times the 2 through, so 2 times by 2x squared is going to give me 4x squared. 2 times by 2xh is going to give me plus 2xh, and that's going to be plus 4xh. So therefore that's equal to 4x squared plus 2xh. Not for 2xh, it's going to be 6xh. So if I do that, now the other thing we know is that h is equal to what? H is equal to that over x squared, so that's going to be equal to 4x squared plus 6 over 6x times by 100 over x squared. So we're going to cancel that out with that, and that will give us a final answer for this of that's equal to 4x squared. That will give me plus 600 all over x. Now if you want to check if you're right, you'll find that there'll be an answer there, and that's exactly what we've got over here. Alright, so the next step, fairly predictably, is to sketch a graph of that. So that's what we're going to do. Go to our calculator. So again, we're going to our function over here, clear that. So what was it again? It was 2x squared plus 600, divide that by x, and then we graph it. So you can see our scale is a little bit big there, so probably just have to change our y scale there, maybe not 50,000, maybe maybe 1,000. Right, graph that. And we probably even sketch our value here, maybe make that say 10. Right, so you get a bit of an idea that we've got past that point. So you can sketch that graph. The other thing I'm really interested in here is obviously the min point. So let's go for our min number 3. Right, so scrolling to the left hand side, yes, I'm over the left hand side there. Let's put in 9. Okay, and then that gives me my value of 5.31, and that's got a surface area of 1.694. Right, so that's what you'd probably label on your graph. Keeping in mind we've sort of done this a bit, so you could sketch that and doing all that sort of gear. Using technology, find the value of x for the inner surface area of the box corresponding. Find the minimal inner surface area of the box and the corresponding value of x. So we are using that vertice point. So that's going to be, I think this is part E, isn't it? So let's just do part E. So we know the point there is, again, 5.31. 5.31 and 169.4. Okay, because this is a graph of x versus surface area, then obviously the minimal value there is the surface area is my y value, and my x value tells me the dimensions of that. So we have to make a statement like min surface area. Hi guys, we're going to look at, just close that, so min surface area of 169.4. Now I think this is in centimetres, so that'd be centimetres squared when x equals 5.31 centimetres. Alright, so that gives you an idea what we're doing there. The last part of this question then is to draw the optimal box shape. So really what it's asking you to do there is to draw the box, which is already drawn up there, and then all you have to do is put the values on there. So we know that's 5.31. So what's 2 lots of that? Well, that's going to be equal to 10.62. And then we know h is equal to 100 divided by x squared. So you can simply do that on your calculator. 100 divided by 5.31 squared. And that's going to give you a value of 3.55. So therefore, we now know the dimensions of our box. Okay, make sure you're putting your units on there. They're all centimetres and centimetres. Alright, so that's that third question, a fairly traditional sort of question, and you probably might get something like that in your test, so make sure you know how to do that.